In this video, I want to talk about a rule called the chain rule. The chain rule is a rule for taking derivatives designed to help us take derivatives where I see a function on the inside of another function. Particularly in this example, I could imagine that y is equal to u squared and u is equal to 2x plus 3. I do the substitution and I get back to this original equation. So this is what I mean by an outside function and an inside function. Of course, this is really just function composition. That I have the squaring function, and then I have the function 2x plus 3. To form their composite, f composed with g of x, or f of g of x, I simply take g of x and I substitute it into f of x. So I think about f of x as being the squaring function, so something gets squared. That something is the function g, and I plug in 2x plus 3. So, just a brief review about function composition. What I want to do is take this function's derivative. So before we learn the chain rule, let's just take this function's derivative without needing it. This is a nice enough function that I could simplify with some algebra. I could just imagine doing the squaring. So let's see, I'll have a 4x squared plus 12x plus 9. And then I could take the derivative, dy dx. 8x plus 12. All right, nice happy example. Wouldn't have to use the chain rule, but let's see if we can use this example to develop the chain rule, because there are functions kind of like this where we can't do any algebra and then take the derivative without needing the chain rule. So let's think about it as that squaring function, and then u is 2x plus 3. Well, if I just ask you to take a derivative of this equation, you might think to take the derivative with respect to u. And that would just be 2 times u. And then you look at this equation, and you'd say, well, I can take the derivative with respect to x, so du dx, and that would just be 2. Right, and two separate derivatives that might have something to do with this. Let's see. So 2 times u, well, I know what u is. U is 2x plus 3. And so this quantity, dy du, in terms of the variable x, would be 4x plus 6. And I look at this and I say, well, that's not what I got over here, but it's off by a factor of 2. If I take this and multiply it by dy du, I think I have what I'm looking for. So my hypothesis is that dy dx is the product of dy du and du dx. And for our specific example, that would be 4x plus 6 times 2. 8x plus 12. And that seems to work. So I think this will be my rule for taking the derivative of composite functions. And when I read this left to right, dy dx is equal to the derivative of y with respect to u times the derivative of u with respect to x. So what I'm thinking is we're going to take the derivative of the outside function, leaving the inside of it alone, and then multiply by the derivative of the inside. All right, well, let's write down the chain rule and then just do another example. All right, so the chain rule itself. If I have a function in that format, y equals f of u, and that needs to be differentiable at u, which is equal to g of x, and g of x needs to be differentiable at x, then I can write down that rule. dy dx is equal to dy du times du dx. What I'd like to do now is imagine that rule, but in my other notation. So what I have is a function y equals, that's composed of a function f and g. F is my outside function, g is my inside function. What I'd say is that y prime is equal to the derivative of f, leaving the inside alone, times g prime of x, dy du, du dx. So the whole idea behind the chain rule is we take the derivative of the outside function, leaving the inside alone, and then multiply by the derivative of the inside function. Let's do another example in this video where we can check our answer, where we don't have to just rely on the chain rule. So let's take the derivative of x squared plus 1 all squared. And again, I can do this with or without the chain rule. I'll start without the chain rule. So what I need to do first is square this. So I'll have x to the fourth plus 2x squared plus 1. And then its derivative would be 4x cubed plus 4x. Now let's see if we get the same thing using the chain rule. In this first example, I think I'll go through the trouble of reimagining this as y equals u squared and u equals x squared plus 1. In the next few videos, I'll skip this step and see if we can go about doing this mentally. So dy dx, dy du would be 2u. Du dx would be 2x. The chain rule says that the derivative I'm looking for is dy du times du dx. 2 times u, but this is where I'm going to remember that u is x squared plus 1 times 2x. All right. 2 times 2 would be 4x, so I need to distribute that through, and I'll get a 4x cubed plus 4x. And so my answers match, and I found the nice happy derivative 2 different ways. One using the chain rule, one using the chain rule, and one using algebra. So there we have it. More examples to follow.